So, in various optic neuropathies, you know that there are some things that are universal between them. And of course, our two prototype optic neuropathies are non-arteritic anterior ischemic optic neuropathy, which is from ischemia, and optic neuritis, which is from inflammation. And they both share similar characteristics. They both have decreased acuity, they both have decreased field, they both have an RAPD, and they both have an optic nerve that could be swollen. In optic neuritis, it might not be swollen. In NAION, it has to be swollen. And what that means is you cannot tell the difference between those two based on those characteristics. However, optic neuritis does have some features that can separate it out empirically, and empirically means we just know that because people have it. And then we have some explanations that might explain why this occurs, but a lot of this isn't really known. So one of the things is pain. So when you have pain with eye movement, that's more likely to be inflammation. But interestingly, NAION also sometimes has pain because sometimes ischemic lesions are painful. So the pain with eye movement is more suggestive of optic neuritis, but it's not absolutely differentiated. In addition, you know that you can have normal acuity, 20/20 acuity in both NAION and in optic neuritis. In NAION, that often occurs because the field defect isn't actually knocking out the center vision. So if you have an altitudinal field defect, you still have half a macula, and half a macula can still see 20/20. In optic neuritis, that's from demyelinating disease, and so in demyelinating disease, it's thought to be a transmission defect, so it's not being, the signal's not being sent properly, and so you might still have 20/20 even though you have optic neuritis and you have a visual field defect. And so when we have functional tests for assessing optic nerve function, those functional tests have differential sensitivities to the underlying etiology, whether that's ischemia, demyelination, or compression. And so some of our tests are just not that good at detecting disease. And you know that from diseases like glaucoma, where you can literally be 20/20 until you're very, very terrible field, because that's not a good test for detecting that optic neuropathy. Same with pseudotumor cerebri from papilledema. They might literally be 20/20 and have a terrible field. So we should not be using the acuity because it's such a gross measure of visual function. And there are other tests that are very sensitive, like contrast sensitivity, but not very specific. So if we do contrast sensitivity on people with optic neuropathies, you're going to detect a lot of defects that you wouldn't have noticed because it's very, very sensitive, but it's very not specific either. And the same thing goes with color vision. So color vision, red desaturation, decreased color is often associated with optic neuritis and spared in NAION, and presumably it's the exact same cause. If you have half a macula, you can still see the colors with that half. If you have half a macula, you can still see the center vision. If you have half a macula, you can still see. But in optic neuritis, even if the field is not an altitudinal, it's diffusely depressed because the signal's not being sent. And that means a high demand system like color differentiation might feel that even if you're 20/20 and you only have mild depression of the field, even though NAION didn't feel anything, because NAION still has half an eye. And that happens because the ischemia in NAION is usually sector. It's like 1/2, so they get sector pallor, sector field defect, and that means your color and your center vision might be preserved. But in optic neuritis, it's not a sector of vascular ischemia, it's the whole nerve. It's been demyelinating to various degrees, and that's why it'll slow the transmission, and in a high demand differentiating system like color or contrast sensitivity, you'll be able to detect deficits in those systems way before the acuity will go. And that's the presumed mechanism for the empiric observation that color vision, contrast sensitivity, and other more sensitive measures of optic nerve function are more likely to be affected in optic neuritis than ischemic optic neuritis.